Now, what you can also notice is periodicity of trigonometric ratios. Because this is a 360 degrees circle, what you can do is you always start from this axis. You can go one full rotation, which is 360 degrees, or 2 pi in radians. You can actually do another rotation. That's going to be another 360 degrees or another 2 pi. But the thing is, you can keep going on and on and on. You can do as many rotations as you can. So what this is is periodicity. So you can do as many full revolutions as you want. So what that kind of tells us is that it's going to have the same value. So it doesn't matter if I do only one full rotation or if I do one and then another little bit and then come back here. This x and y coordinate is going to have the same values. So what we can notice is k is an integer. That's what this little z tells us. Basically meaning it's numbers, just whole numbers. So any integers, we have theta. If you do another whole rotation, so same thing, so cos theta would be this answer. If I do this same angle and another whole rotation, it is going to be exactly the same answer. So if I do another whole rotation, so in this case, if I say k is 1, so if I replace that as 1, it's going to be theta plus whatever 360 degrees. It's going to give me the same exact value. It does not change. Same with sine. Okay. Now this is using degrees, 360 degrees. This is using 2 pi as radians. Just notice that you could write as 2 pi k. The order doesn't matter. Same thing as 2k pi. I think I'm a little bit more used to writing 2 pi k. It doesn't matter which one you use. It means the same thing. Just depending on what your k is. So if your k is 1, that means 1 revolution, 1 full revolution. If my k is 2, it just means you have done 2 more full revolution, etc. And it just goes on and on. It's periodic, so you can go on as much as you want. So that's a little fact that you really want to know. Another something you want to know is tan theta. Remember, tan theta is a gradient. It's a ratio of that sine theta and cos theta. So if we have a look at this specific case, if we want to find when that tan theta agrees again, is when basically it has the same slope. So we have to come back to this. It's not a full revolution, it's basically a half a revolution. So that's a little bit different for tan theta. So if you add 180 degrees, which is half a circle, it's going to be same but negative version of the answer. If you add another half, it's going to turn into a negative as well. So the coordinates change by a negative, but the tan theta itself is going to be the same. So for tan theta, so because we didn't do a full revolution, obviously these x and y coordinates are going to change because it doesn't satisfy this rule over here. But for the tan theta, we can notice that if you only do a half a revolution, you can get the same answer. Alright, so this is called periodic. So these are summary of some of the key kind of things we can summarize. So basically we saw that 180, take theta, so if you do half, it's going to give you the same answer. Similarly with the cos, gives you a negative version of that answer. If you have a negative theta of it, you can move the negative out of the sine theta. If you also have a negative in a cos, it just becomes a positive version of that theta. So these are some rules you can apply to do some algebraic manipulation. Cos of 90 take theta actually becomes sine theta. And sine 90 take theta becomes a cos theta. So all of this, once you do all of these questions, you might be able to see some of these characteristics forming from your questions. But those will be these little blocks of information. You don't really have to memorize it. You can apply and use it because you can have a bit of a cheat sheet.